Welcome to the Explainer. So, if you're in procurement, industrial fabrication, or, managing a manufacturing budget, you already know that waterjet cutting is absolutely vital. It gives us that incredible high precision without the nightmare of heat distortion. But, as we step into 2026, the landscape is definitely shifting. Between fluctuating abrasive supplies and those rising energy costs, just relying on the old standard hourly rate is no longer a safe bet for your budget. So, let's dive right in and walk through a true step-by-step guide to actually optimizing your manufacturing budgets for waterjet projects.
To do that, we actually need to start by challenging a really common assumption. Is your reliance on base hourly rates actually destroying your budget? I know, when you're looking at an RFQ, it is so tempting to just hunt for the lowest hourly number. But here's the real secret to waterjet costs. You have to think of the machine exactly like a taxicab. The second that waterjet nozzle opens, the meter starts running. Your biggest expense is simply machine time, so every single minute that nozzle stays open is eating directly into your manufacturing spend. To help you stop overpaying on those RFQs, we're going to follow a really clear 5-step budget optimization playbook today. First, we'll decode those hourly rates, then we'll calculate material impact, optimize your edge quality, uncover the hidden consumable costs, and finally, implement some smart procurement strategies. All right, step 1. Decode hourly rates. We really need to understand the true cost of machine time. You see, global shop rates fluctuate dramatically based on what the machine can actually do. And suppliers aren't just making these numbers up. If you're looking at a standard job shop, you're usually looking at roughly $80 to $115 an hour, which is great for simple shapes and common materials. But as your parts get more complex, like if you need a high-pressure 5-axis system for aerospace geometries, you're stepping into the high-precision tier. That runs between $125 to $165. And if you're dealing with extreme thicknesses like over 6 inches or hazardous materials, specialized shops are going to command a massive premium, anywhere from $170 to over $210 an hour. And this right here brilliantly illustrates exactly why you can't just shop for the lowest hourly rate. Let's compare an older, slower machine with a low rate against a newer, much faster machine with a higher rate. Sure, a low hourly rate looks amazing on paper, but think back to our taximeter. If that older machine cuts at half the speed of the newer system, your meter is running twice as long. Because the shop factors in things like machine amortization and labor, that so-called cheap hourly rate on the older machine often leaves you with a drastically higher cost per part. Which leads perfectly into step 2, calculate material impact. Let's look at controlling the clock with density and thickness. Ultimately, the density and thickness of your material entirely dictate the machine's feed rate. Take half-inch aluminum, for example. It's a soft metal, meaning it cuts super fast and uses way less abrasive. But swap that out for half-inch stainless steel, suddenly you drop down to a moderate speed. Move over to super alloys like titanium or Inconel, and wow, the cutting speed slows to an absolute crawl, while the consumable wear just skyrockets. And for any material over 4 inches thick, the cutting speed doesn't just gradually slow down. It drops exponentially, causing a massive spike in your price per inch. Let's move to step 3, optimize edge quality. This is all about the hidden cost of over-engineering. This is honestly where buyers make some of their most expensive mistakes. Waterjet programming software generally offers 5 distinct quality levels, ranging from Q1 to Q5, and this scale directly manipulates your total time on the machine. Q1 and Q2, those are basically fast separation cuts. They leave pretty rough edges and are perfect for internal structural parts where nobody's going to see them anyway. Q3 is your middle ground, basically the industry standard for general fabrication. But Q4 and Q5, those are painstakingly slow, highly precise finishes. They really should be reserved only for mating parts that need to fit together flawlessly or for highly aesthetic edges.
So, here's a crucial multiplier you absolutely need to remember. 3. Specifying a Q5 finish for an entire part when only one single edge actually needs that precision is such a common mistake, and it will literally triple your waterjet cost. Seriously, you are forcing the machine to crawl at a snail's pace around the entire perimeter of your part, just keeping that taximeter running for absolutely no functional reason. Always match the correct Q level strictly to the specific edge requirements of the part.
Okay, step 4, uncover consumable costs. We're going to take a little peek behind the supplier's curtain here. Knowing the internal operating expenses your suppliers face actually gives you a ton of leverage to negotiate better contracts. You might actually be shocked to learn this, but for most operations, the cost of consumables will exceed the total cost of the machine itself over its lifetime. It's crazy. A staggering 50% of a shop's total operating expense goes strictly to the garnet abrasive used in the water stream. Better garnet means faster cutting, but it costs way more per ton. And most of these machines are chewing through half a pound to 1.5 pounds of this stuff every single minute they're running. And it definitely doesn't stop at the abrasive. The physical wear and tear on these machines is just extreme. The mixing tubes and orifices, which focus all that high-pressure water and abrasive, wear out and have to be completely replaced every 40 to 100 hours of operation. On top of that, those massive high-pressure intensifier pumps need really frequent seal changes just to prevent sudden breakdowns. When you understand these rapid consumable wear rates and intense maintenance schedules, it makes total sense why suppliers charge what they do and why machine time is treated like gold.
Finally, let's step into our fifth and final section, Step 5, Implement Smart Procurement. Let's talk actionable tactics for your next RFQ.
Now that you really understand how these costs are built, here are your actionable takeaways to reduce waste and protect your 2026 budget. First, zero in on your nesting and logistics. Super efficient, tight nesting minimizes material waste, which is absolutely critical when you're paying a premium for expensive alloys like titanium. Just ask your supplier point blank about their nesting efficiency. Second, seek out suppliers who actively utilize garnet recycling systems. Because they reuse that expensive abrasive, they're way less vulnerable to global market fluctuations, meaning far more stable pricing for you. And third, evaluate the shop's actual machine maintenance standards. A well-maintained machine cuts faster and breaks down less, straight up saving you money on the final invoice.
So I want to leave you with this final thought. Are over-engineered specs draining your 2026 manufacturing budget? Take a really hard look at your latest RFQs. Check those edge quality callouts, consider the material thickness, and ask yourself if you're accidentally leaving the taximeter running on your Waterjet cuts. I really hope this guide empowers you to stop overpaying for machine time and start fully optimizing your fabrication spend. Thanks so much for joining me on this explainer, and I'll catch you in the next one.